We're in a larger unit on solving equations. You'll realize that today, that we're actually solving not just polynomial equations, but actually all kinds of kind of specialized equations. Some of them that you would have seen in algebra, maybe some things that you didn't realize about them, and maybe some things that you didn't see in algebra. Today we're actually going to solve two types of equations, radical and absolute. I have a feeling you have some exposure to both of those, but again, probably some things maybe you haven't realized or just need to touch up on. This is a radical equation. Okay, it's got a square root. A root symbol can also be called a radical sign. I dare you to solve it. Okay, that's kind of my way of saying there's something special about this equation, but solve it. And don't worry. Don't worry if you aren't sure what's special. I encourage you to do what you think is normal because that's what I expect you to do. You should be doing some inverse operations. If you're subtracting 5 as your first step, that's good. That's what you should be doing. If you're squaring both sides, that's good. That's what you should be doing. So why am I daring you? What's special about this? Again, if you subtract 5, you get the square root of x minus 4 equals -3. I would expect that that's pretty normal for you. If you square both sides, of course, you want to be careful. I know you've heard it more than once that when you square a negative number, it obviously turns out positive. And I hope that you're adding 4 to get 13. Of course, we're not superstitious in here. The number 13 isn't why this problem is special. Not because of that number specifically, but actually there is something kind of wrong about this answer. Geez, what could be wrong about this answer? Let's do something that we should do more of. Sometimes we don't do it because we don't have to, but sometimes we don't do it because we don't realize we should, and that is to check our work. Now, if you take the number 13 and plug it back in, of course, I'm sure you're proceeding with a little bit of caution. Maybe there was a teacher at a time that said that really there should be a question mark over this. Yeah, technically, because we're trying to figure out if they're equal. So just be careful about that. But I think I'm getting here 5 plus the square root of 9. 5 plus the square root of 9. Well, last time I checked, that should be 5 plus 3. And that doesn't look like it's going to equal 2. At least, again, not last time I checked. Now, this problem brings up two things we should be kind of cleaning up as an honors trig student. First of all, and I think somebody asked about this sometime in here, it's not that this could be plus or minus. It's not that it should be plus or minus. Say what? I thought square roots were always plus or minus. What you have to understand is that the problem was given to you as the plus square root. It was given that way. It wasn't given as plus or minus. You say, but again, I thought it was always plus or minus. That's if you take the square root of an equation. That's if you put a square root into a problem. I gave you it this way. I gave it to you as the plus. Honestly, I could have given it to you as the minus. I could have said 5 minus. But the mere fact that it says 5 plus 3 says that there's no way that this number 13 is going to check in this problem. Okay. The other thing that this brings up is more of a bigger issue, and that is anytime that you solve a radical equation, you might get an extraneous solution. And we want to get comfortable with that word extraneous. It's just kind of a fancy word for an extra answer, more specifically, an extra answer that's not really an answer. So the number 13 is extraneous. And again, I just want you to be aware that this can happen. It actually can happen from now till the end of the chapter, because we're going to be dealing with special equations. So to make this problem right, or to sort of finalize it, we could do a couple things. We could write the word extraneous beside 13. I'm going to assume that if you write that you understand that that means that it's not a solution. Since there's no other solutions available, we also could give the final edict that there is no solution, which I know you've seen that before. Let's look at some more radical equations. Maybe we can make some other conclusions. Here I've got negative 27 equaling 3, the cube root of x plus 4. Negative 27 equals 3, the cube root of x plus 4. Again, make sure you understand from prior learning that a cube root is also a radical. Obviously, it's of a different root. This time it's an odd root of 3. Now, nothing real fancy here. Again, I would expect that you're going to divide. We always want to work from the outside of an equation. You guys have done that for many years. So we divide both sides by 3. And it's time to get rid of the cube root, which of course we just have to raise it to a power that's going to cancel. This time a big old 3. We'll raise both sides to the third power. Now, negative 9 to the third power, might feel like you want to use a calculator for that. That's fine. I probably would too. Of course, it's negative 9 times negative 9 times negative 9. Okay, I'll give you the answer, but just think about it a little bit. It should be coming out negative. And it's actually a perfect power of 3. I don't know if we have those memorized. I know I don't have all of them, but negative 729 is what equals x plus 4. Of course, if you subtract 4 more, now you're all the way down to negative 733. I hope that this problem kind of speaks to you and says, is this really the solution? Well, let's check it. Now, a word on checking. You should do this. You actually should be doing this from here to the end of the chapter. If you don't show it, but do it, okay, no problem. If you don't show it and don't do it, well, you run the risk of not knowing if your solution is correct. So what I'm basically saying is it's going to be up to you how you treat these checks. Some of you will check it in your calculator. Some of you will just check it mentally, and I hope that none of you forget to check it, but there is always that possibility. Now, maybe you're wondering, in real honesty, how do you do the cube root of negative 729? You could just reverse what we just did a moment ago, because the cube root of negative 729 is 3 numbers that multiply by negative 729. We just figured that out, that it's negative 9. Your calculator also has a cube root button. It's in the math menu. And it never hurts to remember that any root can be thought of as an exponent. I prefer that because then I don't have to search for special buttons and menus. But a root of 3 is the same as an exponent of 1/3. If you're a little need to brush up on that, we actually will be revisiting that idea in a few weeks. But in any case, it does come out to be negative 9, and there's nothing funny going on with this problem, because negative 9 times 3 is negative 27. Now, there is a little bit of a kind of a, I guess I could say it's a little trick or a little shortcut, but the truth is, back up here in the second step of both these problems, we had something that is always going to be worth noticing, and that is if a radical is equal to a negative number. Now, if a radical is equal to a negative number, and the radical is of an even, so square root is even, that's going to be a no-no. But if a radical of an odd, so an odd root is equal to a negative, that's going to be okay. This is a little bit of a, if you notice this, you might realize that as you work through the problem, not going to work, is going to work. Okay, even odd. That's not something I'm going to have you memorize, but it's something that you might want to notice. It could help you. Any questions? Anything just kind of sort of a getting started here? Okay, because there's some more to do, but let's let this example, square root of x plus 7 minus x minus 1, let's let this problem speak to us a little bit. I got the square root of x plus 7 minus x minus 1. Now, it's definitely a radical equation, and radical equations will always require us to isolate the radical. Isolating the radical, in other words, moving other items away, is typically, and I'll say it's really always, the strategy that's needed so that we can proceed to cancel that radical. I have that up here as like a little statement. I know you've heard this idea before, but it's actually so important that you always isolate the radical before you do any other algebra. Okay, so be careful about always isolate the radical before you do other algebra. Now, really the reason for that is so that we can square both sides. And depending on where you're at with this problem, are you squaring both sides in this manner? I know it's not the first time that you've heard this, but it's important to revisit this and make sure that we're squaring x plus 1 like a binomial. Okay, like a binomial. Of course, when you square x plus 1, you do not just square x and 1. Remember, that's a math teacher's nightmare. We don't want any math teacher nightmares. Instead, you're going to do the FOIL method, or maybe you know a little shortcut that allows you to get x squared plus 2x plus 1. And now look what we've made. Now look what we've made. Okay, it's a polynomial. Okay, even if you're not up on the language, it's a polynomial. Polynomials love to equal 0. And of course, that's what we just spent the last 5 days kind of brushing up on. So again, I kind of stand here and say, don't be surprised. Don't be surprised if one of these radical equations turns into one of these. It's not the hardest polynomial. I don't think we need the quadratic formula or synthetic division. Do you think maybe some problem might? Maybe. Again, do you hear me? We don't need the quadratic formula. We don't need synthetic division, but don't forget about all those tools. Thankfully, it's just back to a simple tool. I think we call it a sol. We're just doing some simple factoring. Now, if you're feeling good, good. I want you to feel good about what you're doing. But if you honestly stopped right here, or if you're kind of saying -3, -2, right? I don't know. Is it right? Obviously, what I'm insinuating here is you have to check your answers. So try to get yourself in the habit of doing that. Now, when you check -3, you have to check it in the original equation. When you check 2, you have to check it in the original equation. Are you tracking with that? You have to go back to the very beginning. Now, some people will just do this check mentally. Some people will write out. As I mentioned, I'm okay with whatever you decide to do. Sometimes it's the check that gives people the most trouble. I get it. You're trying to just do some arithmetic or order of operations. Even myself, as I look at this, I realize I just made a mistake. I wrote the number 4, but it should be a 3. So now this is going to be 2 plus 2. You know, you're like, 2 plus, should it really be 2 minus 2? No, it's 2 plus 2. Okay, the square root of 4 is 2. Don't just put a plus or minus right here. It wasn't given as a plus or minus. No, it's a big no. If you plug in 2, and this will probably be the last time that I really walk through this, but I know that it's the check that sometimes is what gives people the most trouble. So if we check the number 2, we get the square root of 9 minus 3. Okay, that's 3 minus 3. That is equal to 0. Okay, so a lot of times when it doesn't check, we're kind of like, did we make a mistake? It does check here. We get 3 minus 3. Now, I crossed this one off. You saw that I did that. That's acceptable. If you don't cross this one off, or sometimes people will circle it, we'll get the idea that you want it to count. If you don't cross anything off, I'll assume you want them both to count, which in this problem is a no-no. Hey, they might both work. One of them might work, and there's a chance that none of them work. That's not normal, but again, they both could work. One of them might work. There's a chance that neither of them work. We're going to do one more radical equation. Okay, we're actually doing 2 types of equations today, but let's do one more of these. Square root of 2x plus 3 plus the square root of 2x equals 3. Square root of 2x plus 3 plus square root of 2x equals 3. I don't know if you would have done this had I not said anything, but I do know that we want to not do this. This would be a pretty elementary mistake. If you catch yourself doing that, try to stop before you proceed. That's bad algebra. Okay, that's kind of like saying that I can sort of distribute a square. If you look at the second statement I wrote up here, I wrote it for a reason. You want to isolate the radical. Now, if you're saying, yeah, but there's 2 radicals, okay, so what we're going to do is we're going to isolate just one of them. We're going to isolate one of them. You could choose either one, but I'm going to choose to isolate the square root of 2x plus 3. Basically, I'm going to subtract the other square root to the other side. Okay, so we're trying to kind of follow the suggestions, and we're isolating, and here's why. Okay, here's why. When I square both sides, I actually get rid of one of the square roots. Are you tracking? I get rid of the square root on the 2x plus 3. Okay, so something's happening here. Now, when I square the other side, we have to be willing to do some fancier foiling. Some fancier foiling. How do you guys feel about this? Okay, you can kind of go on your own, or you can just keep listening. 3 times 3 is 9. Now, 3 times negative root is negative 3 roots. And then it happens again. I take 3 times negative root, and I get negative 3 roots. That's negative 6 roots. Notice that I didn't multiply to the inside, but rather I basically added the negative 3 roots to get negative 6. How about this last one? Again, some people have different knowledge of this. Negative root times negative root. Well, first of all, it's 2 negatives. That's going to be a positive. Some people would say that the roots cancel out. That's fine, as long as you understand that they cancel out to just be 2x. Some people would say that the roots can multiply to be 4x squareds. And when you do the square root of those 4x squareds, well, you're going to go back to 2x. So when you do the rest of your foiling, make sure that you only get 2x. Okay, the square roots, again, they either cancel out or they simplify to be 2x. You see what you have now? you've got another radical equation with one radical. So you kind of start over. Okay, and I don't think the rest of this is going to be too much of a surprise, but we can certainly go together here. By the way, the two x's just happen to be the same. So however you would like to know that they're just going to subtract away or cancel each other out. So I've got one square root. I can kind of isolate it. Subtract 9, pretty basic stuff. Subtract 9, divide. Okay, now in the back of your mind, you should be thinking, is the answer I get here legit? Okay, well, let's proceed. Let's square both sides. In fact, that just keeps us at the number 1. And we arrive at 1/2. We arrive at 1/2. This is the type of problem that maybe we can check it mentally. If you're going to be one of those people, if you plug 1/2 in up here, maybe without your calculator, that's just going to be 1 plus 3. That's the square root of 4. If I plug 1/2 in here, I'm going to get the square root of 1. I'm seeing 2 plus 1. Okay, it does check. If you plug in 1/2, it does check. I'm just going to leave it alone. Okay, the main moral of that problem was how we squared both sides twice, and we carefully did some isolating. Radical equations, anything for the good of the cause. Okay, well, I'm going to move to a different topic. I hope you don't boo and hiss too much. I think you can handle 2 today. At least that's what I'm expecting, because the other kind of equation you've also been exposed to, absolute value. Absolute value. Now, first time you studied absolute value, probably in a pre-algebra or algebra 1, you should have had a little bit of a discussion about its definition. Remember that absolute value is really distance from zero. Distance from zero. And it doesn't hurt just to take a moment and remember your most basic absolute value equation, something like the absolute value of x equals whatever your favorite number is, equals 5. Now, you're not going to see one like this on a test, but it still doesn't hurt to remember that this is basically asking what numbers, what x's have a distance of 5. What numbers on a number line have a distance of 5? And that's, of course, why you would have said, well, there's 2 numbers. There's a 5. Of course, 5 has a distance of 5, but we know that there's negative 5. And so absolute value seems to have this idea that we can be a positive and a negative. Okay, and yes, that's still true. It's going to be true when we look at some problems that are a little more algebraic. I think I have this up here as sort of just our main reminder, if you need to be reminded of that. The main thing is that you apply that to, to an equation that's more algebraic. We're just going to do one of these. Okay, so try to take this in. Try to take everything in. So we've got the absolute of x squared minus 3x, and that's equaling negative 4x plus 6. Obviously, it's a little more algebraic. Okay, but the neat thing here is that you can take to the bank this idea of equaling a positive and a negative. In other words, understanding that the absolute value piece, the x squared minus 3x, can and will equal. Now, when we say the positive, that implies that it's going to be the same signs. So it's going to still equal negative 4x plus 6. And of course, we'll be able to go on our merry way and solve that. But let's make sure that we understand that to equal the negative really means that the x squared minus 3x piece would have to be the opposite, would have to equal the opposite of this side. So now we have a 4x and a minus 6. Okay, so it's kind of double your fun. Now we have two equations to solve. And of course, both of them are just blasting polynomial. I don't want to have all the fun. You guys, as you're already doing, why don't you solve those? Set them equal to 0. Decide if you can factor them or what tool you want to use. Okay, I want to be honest with you that I would expect that you can solve these. But are you checking them? The second one is a little interesting. When it comes to factoring, you have to choose the minus 6 and the minus 1 so that it can factor and multiply back to negative 7x. Again, I would expect that you can find these 3 or 4 answers. Okay, it's kind of fun working through a little problem like this where you can factor and everything seems to kind of work out. Or does it? So what I'm implying is that you do have to check for extraneous solutions. And from my experience, that tends to be the thing that gives students the most trouble. Are you plugging negative 3 back in very, very carefully? Are you plugging 2 back in? You really should think through a few of these before I give you a little exit question. Maybe you can do it mentally. Maybe it helps to write out some stuff. Okay, there's lots of negatives going on here. When you check negative 3, you actually get the absolute of 9 plus 9. The absolute of 9 plus 9. Being careful with the negatives. Apparently equaling 12 plus 6. Okay, well that's a yes. Okay, 18 equals 18. When you plug in 2, you're going to be, well, let's see what happens here. Listen, it never hurts to kind of be sharp about some things. I'll be honest, I hadn't thought about this before I taught it to you, but there's a reason right now we could say this ain't going to work. If you trust your math, over here is negative 8 plus 6. Well, guys, negative 8 plus 6 is negative 2. Again, if you trust your math, you would say there's no way that an absolute value is ever going to be negative. I can figure this out over here. it comes out to 4 minus 6. But again, this side is going to be positive 2. This side is negative 2. Not going to work. Okay, so we end up crossing off 2. And did you spend a little time checking the other ones? I'm going to tell you, in case you need that confirmation, that 6 does not work. 6 does not work, but 1 does work. So we really end up with 2 solutions, negative 3 and 1. Okay, but it doesn't mean you made a mistake, and there's really no rhyme or reason that you would know that without solving it and checking it. Listen, I'm happy to talk to you more about anything that happened, particularly with this last problem.